Hey everyone. Super excited to join in the second instance of AIM webinar series with your, I guess, webinar host from the second webinar series so far, Gav. My name is Gav. I'm one of the co-authors of the project, and my esteemed guest is Gore. I guess the other author of the project. So we have both created AIM. So yeah, Gore, why don't you introduce yourself?
Thanks, Gab, for the interaction. I'm Gore. I'm co-author of AIM. I'm mostly focused on the product and on the tech side of AIM. And today we will go over and have a deep dive on AIM Explorers and find out how they work and where can they be helpful, actually.
So this is going to be a high-level kind of go through of Explorers. It won't be, we will with a bunch of examples, but we'll just try to cover like general, like an Explorer ground, explore as much of the Explorers we can. Yeah, so pretty much what we're going to happen, we will go through a quick kind of slides to kind of give an idea what are the Explorers and how to think about them, what are they built for. And then the second part, we are gonna have a number of questions pretty much around the slides and in general examples of like with the screen share and with, you know, real demo and everything. So we are excited to get started. And I think, Gore, you can share your screen now.
Yeah, I will share my screen now. A minute, please. Okay. Yeah. So do you see my screen?
Yeah.
Yeah, awesome. So yeah, this is the webinar on the AIM Explorers. We'll have a deep dive and we'll learn how to compare large amount of AI metadata and how to visualize it and compare large amounts of multidimensional metadata, actually. Today's agenda is the following. We'll go over the concepts and limitations of AIM Explorers. We will have a deep dive into AIM Base Explorer and learn how it works. We will go through comparing multidimensional data, and we'll have a look at metric explorers and also the other explorers that AIM enables. So this is today's agenda, and let's move forward. Explores concept, comparison, limitations. So the multidimensionality of AI metadata. So AI metadata is inherently multidimensional, which actually means that each tracked run or each tracked sequence, such as metric or image sequence, might have large amounts of dimensions attached to it. Think about it like learning rate, batch size, dataset metadata, or even the context subset of the metadata that was generated from, like training loop or validation loop or training loop. So these are all dimensions that metadata is generated from, and we as AI practitioners and machine learning researchers, engineers, have to actually learn how model performs and be able to compare models across performance of models across lots of runs, experimentation, and so on, to be able to learn the hidden patterns and builds actually models faster. We will also explore the limitations of the explorers. Actually, the limitation of explorers is the 2D screen where all the metadata is visualized. You have only one screen. The only way to visualize data is 2D screen, and we will learn how to group metadata to be able to learn patterns the best way, actually. What is an explorer? Explorer is a visual comparison tool for multidimensional metadata. So what Explorer actually enables us is to query, group, and visualize a large number of tracked sequences, AIM sequences. You can think of AIM sequences as tracked metrics or image sequence or figure sequence and other type of metadata, which can be text, I don't know, and any type of metadata, actually. This is what Explorer for. They just visualize the tracked metadata and help to group a large number of tracked sequences to enable us easily learn hidden patterns. Basic Explorer. So we implemented abstraction that's called the Basic Explorer, which actually enables us to build explorers on top of it. It's just a couple of lines of code to create a custom explorer type, be it a metric explorer, the text explorer, or figures explorer. These are all explorer types that help to visualize and group and aggregate and analyze a certain type of metadata. Correspondingly, like metrics, texts, which are actually sequences of strings, figures, which can be plotly figures or matplotlib figures, and other type of tracked visualizations. Yeah, so this is the Basic Explorer is actually the tool implementation and abstraction that works under the hood of explorers that you can access in the AIM, via AIM. Metric Explorer. Metric Explorer is a certain tool designed to explore, query, group, aggregate, visualize certain type of metadata, metrics. So Metrics Explorer, you can, via Metrics Explorer, you can write arbitrary Python expressions over all the tract of metric sequences, fetch them, manipulate them with lots of controls that are available in Metric Explorer. For example, zoom in, zoom out, manage and adjust highlighting controls, zoom in, zoom out, and so on, to be able to capture the hidden patterns of tracked metrics and learn what model and what patterns actually impact the certain model to behave in the most performant way. In addition to that, Metric Explorer also helps to group metadata according to certain dimensions that you have already tracked, like hyperparameters, which I already mentioned, which can be learning rate, batch size, and other types of metadata that you can set via SDK. Basically, any type of custom argument can be tracked in AIM, with AIM, and be explored via explorers. I will show it later on how you can track and group by them or fetch by them and aggregate by them to learn how model performs. And AIM also enables and provides other explorers as well, such as Text Explorer, Audio Explorer, Image Explorer, Figures Explorer, Params Explorer, or Scatters Explorer. These are all built-in explorers that you can just start using out of the box when you install AIM, and you also have the ability to, as AIM is open source and is fully open, you can also extend Basic Explorer and build custom explorers based on that, actually. So this is a very brief introduction to AIM explorers and how they work and what they are.
Thank you, Gor. Thank you so much. I really appreciate your presentation. We're going to open up for questions towards the end, but for now, we'll just continue. Like I have so many questions over this presentation. So what I'm going to do, I'm going to ask like two groups of questions. We'll just kind of ask around this presentation about some of the slides. And then I think the second group, we can just do a more like hands-on examples and, show what's possible to do with explorers right now on AIM. So one of the biggest questions that I get from the users, and that I got even myself once in a while, even though they have a little bit of experience in working in this, is why the UI? Have you looked into other ways to compare large quantities of metadata? Why this kind of a UI? Well, because it's a kind of a weird, unusual in that sense UI.
Yeah, so actually, when you have large amount of tracked data, basically large amount of data, to be able to compare them, you basically need to actually group them by a dimension to learn patterns that can affect actually. And this is what AIM-UI enables us. It actually on the bottom line, it enables us to do two main functions. It enables to write arbitrary queries on top of track data. So for example, I want to query the runs that have learning grade that equals to 0.1. So on the first stage, you just query the necessary runs and the necessary metrics or the other sequences like figures and images. This is the first phase. And on the second phase, to make sense of the patterns on top of that data, you have to group them by some dimensions. On the UI side, when you have to learn underlying patterns, you have to kind of group them and see via visualization styles, I would say. So for example, if you want to analyze large number of metrics, you have to just fetch them and be able to, for example, color them by certain color. For example, I have train and validation metrics. I want to analyze them, and I just color train and validation by different colors. So I have two groups of metrics that have blue and green colors, blue correspondingly for training glasses and green for validation glasses, for example. And then I want to also be able to analyze them and learn patterns like how learning grade affects training. And I can, on top of it, group by learning grade. And I can do it by color or by stroke style, for example, as well. So if I grouped my metrics with metric name by color and learning grade by stroke style, I will have, for example, 4 groups. Each one of them will include metrics correspondingly for losses that have 0.1 for training loop, losses for 0.1 for validation loop that are stroke styled with, for example, green and dashed strokes, and so on. It just enables me to visually and easily differentiate how different the dimensions and parameters affect certain training. This is actually what explorers do. They just enable us to fetch and group certain group sequences by certain parameters, and enables us to easily distinguish all these metadata by visual, visual parameters, probably like color, stroke style, and access, for example, subplots and other type of visualization ways.
So it's pretty much, there is at a fundamental level kind of three sets of kind of three sequence, like sets of things that people can do with the explorers, right? One, to be able to query search the kind of data, the sequences that you're going to try to like understand better. Second is to be able to kind of play with the dimensions in terms of like, you know, dividing them in as per like some of the existing dimensions, like grouping them in various different ways, such as, you know, adding them color, showing them in different charts. And then the third kind of step is then actually playing with the values, say like with the X, for instance, when it comes to metrics, play with the X axis, or, you know, yeah,
exactly. This is what actually explorers do. And also on top of that, users are able to, so users have different types of tools and controls to manipulate the data as well. As I mentioned, they can, for example, I can set interpolation mode, I can set zooming, I can set scaling and other types of manipulations as well on top of fetch and group data to be able to analyze even very deep patterns.
So when it comes to you know, tracking all sorts of different sequences and exploring them, is there such thing as like a unit of visualization for each type of data? Because there's so many different kinds of data
Yeah,
that one can
yeah.
track.
That's a very good question. And I can just give some examples. For example, if you have tracked number of sequences of float numbers, the best way to visualize number of sequence of float numbers is actually a line plot, a line chart plot. If you have tracked, for example, images, the best way to visualize it isn't just a visual web image or a slider that you can move backwards and forwards to analyze images. For example, plotly images, the best way is to visualize them as plotted figures on the website, and so on. So for the same example for text and other type of metadata, audios, videos, and etc. So each type of metadata has probably a convenient way to analyze it. So here you can see a metric explorer that visualizes set of sequence of float numbers, for example.
Mm-hmm. So you mentioned about the base explorer. So is it really true that I can create my own explorer? Is it really like, how does that work? In a brief few sentences, if you can answer.
Yeah, of course. That's a very good question. So when we built AIM version 2, we built these explorers. Then we found out that community really loves it, and there is a lot of benefit of using explorers. And we started building more explorers, but we started to think about creating some kind of an abstraction that will enable us to build explorers faster, to be able to extend them faster. As you know, in machine learning, you have to track a lot of different types of metadata, and you sometimes need to visualize them in a different ways. So we started thinking and building a way to, so we asked the question, what's the best and most easy way to create own visualization. So we created a tool basically for us that we can add explorers much faster, and we called it as base explorer. This is a foundation for all the explorers, and all the explorers are built on top of that. All the explorers, I mean version 2 explorers, and they are much more performant compared to the older explorers, and it's much more easier. It's much easier to extend and create your custom explorer based on base explorer, and add custom explorers, custom manipulations and interactions based on existing explorers, for example. And I remember one like a community member just added there's explorer that enabled to track and explore geometric data and visualize it via AIM. And it was just a few files, 2-3 files with a few lines of code. It's very easy, and we basically implemented it at first for us, but then we learned that community also builds their own explorers actually on top of that.
Yeah, it was fascinating to see that happen some time ago. So it looks like there have been an evolution of these explorers. So it's been the metric explorer first, then what's this new, from what I understand in this image, we have like the classic metrics explorer and the V2 is metrics explorer. What's the difference between those two?
So basically, if comparing just metric explorer V1 with metric explorer V2, I would say the most so the key part is basically performance. V2 Explorer, V2 Metric Explorers, my Metric Explorer enables us to query and visualize a much larger set of metrics that V1 used to do. It's just performance, from just performance purposes, it's just faster. And also from customizability and extensibility side, it's led us to extend it in a way that suits some certain task on certain way of visualization easier. You can just add a few lines of code and have your own custom manipulation control. For example, as I already mentioned, it can be interpolation, it can be an aggregation function, it can be new aggregation function that you can write for yourself or for a certain task, for example. So bottom line is that there are two key points. The first is performance, it's much faster, and the second one is extensibility. You can extend it and create new explorers, new controls very easily.
Awesome. I guess it's now time to get to some demos and some examples, some real examples. We have talked through kind of the hypothetical fashion so far, and let's show how they work, and let's see what the explorers can do.
Yeah,
for real.
yeah, of course. Let's at first explore Metric Explorer. It's one of the most used explorers so far. And here I have a demo. It's basically a neural translation demo. Here are 56 runs, which have number of metrics, tens of metrics. And now I can just navigate to Metric Explorer. I already have filled in, I searched just and queried loss metrics, for example. And they are already actually grouped by subplot. I will remove it to just see how they are visualized by default. So this is the default visualization. Here are all losses visualized in a single plot with different colors, each corresponding for each representing a single run. And for example, I want to divide loss metrics by a subset, by train subset and by validation subset. I can divide this number of metrics into different charts just by writing and selecting context subset. And now I have 3 charts. Each chart includes metrics that represent that are generated in a certain loop. For example, validation loop, train loop, or test loop. And now I can easily distinguish them. What I will do next, I will just color them by, for example, learning rate. And it will enable me to see how different learning rates impact the training and actual model performance. And I can also group them by, can aggregate them to see the aggregated value, for example. And besides, I can actually group them or aggregate by all the tracked hyperparameters that I set when running the training. For example, pooling, seed, max tokens, filter dropout, and so on. So just by a few clicks, I can learn the underlying pattern that helps me to decide how should I run my future trainings.
Mm-hmm. Gore, can you just go through like what explorers are currently available on AIM?
Yeah, of course. So
just at the high level.
Yeah, sure. So there is Metric Explorer, of course, that I just demoed. There is also Parameters Explorer that helps to learn correlation between different parameters. And on this demo, I can, for example, select preprocessing method. I can select align. I can select dropout, learning rate, max K, max tokens, and see how this all, what kind of impact this all have, for example, on the best loss. And this all is visualized via high parameter visualization plot, which have different axes. Each parameter represents a single axis. So here is dataset preprocessing, hyperparameter align, dropout, learning rate, and I can just now hover over the best loss and see what parameters help impacted the training the most. So there is actually hyperparameters align is equal to XLM, and dropout equals to 0, where learning rate is 0.0007. It's just a few clicks and you can easily analyze and learn the impact of different parameters on the overall training run and model performance. So this was Parameter Explorer, or there is Text Explorer.
If you just go through like without like a specific example, just to show what explorers are available.
Yeah, of course. So there is Text Explorer, which enables to explore texts. Let me find the demo where I have tracked some text samples. not for all the models or all the tasks you have to track text, as you may know. And so here is Text Explorer, for example, where it visualizes all the tracked text sequences. And this is particularly beneficial for tasks when you generate, for example, when you work with NLP tasks and generate texts. And this is also beneficial for LLMs when you have prompt tuning and other stuff, and you want to analyze and learn how different methods impact your outcome, for example. And you can see there different types of text sequences are grouped and visualized with different colors in different charts. And for certain tasks, you can group them correspondingly to learn the hidden parameters. So there is also Images Explorer when you can track and analyze images. So this is a image generation tasks. It's a lightweight gun trained on MedFaces dataset. When, for example, you can easily see and explore how the model evolves and how the generation actually evolves. So at first there is just like images, and then you start to distinguish some patterns, and eventually they become faces, and you can also explore the interpolation between faces and so on. Basic explorers are an abstract way to track, to visualize your sequences in the most convenient way, actually. So here are my generations.
So Gor, just a quick question. So it seems like there's this, so you can compare the metrics, you can compare the parameters, you can compare the text, you can compare figures, audio, scatters. Can you show me an example on a scatters explorer and how it looks like? What are the types of things you would be interested to look at when it comes to scatter explorers?
Yeah. So in case of the translation task and overall, actually, Scatter Explorer is I would say a corner case of hyperparameter explorers. So hyperparameter explorer helps us to visualize multidimensional data, whereas Scatter Explorer helps us to visualize two correlations between two dimensions. It's basically a scatter chart when I can, for example, select the best loss for subset test, and I can select blue score for subset test and fetch the corresponding values for all the runs and see how it behaves. I can also add the trend line option, add the trend line and select option between linear regression or Loess and see how they, what type of correlation these two dimensions have in the context of the training.
Awesome. So you mentioned there is a figures explorer.
Yeah,
I've heard that figures explorer has been built on top of the base explorer, whereas the images explorer, it's been like an intermediate iteration, like the explorer that led us to the base explorer. So can you just go through the differences of the experience with between the images explorer and the figures explorer?
Yeah, that's a very good question. So Figures Explorer is actually built on the base explorer, whereas Images Explorer is built from the scratch, and we learned a lot from Images Explorer and the usage patterns that the community used, and we came to the base explorer, which also the bottom line is that it's more performant, that it enables to easily customize it, and for the contributors, it's easier to add more controls and more visualization manipulations. For example, here I just tried to fetch all the figures for all the runs with names, test totally and volumetric validation. This is a text-to-speech training task. And basically, Figures Explorer help to, again, visualize tracked total figures, and you can arrange them in a two-dimensional grid, and you can specify x-axis and y-axis how you want to see them and how you want to compare them. But just because I just fetched all the figures, it's a bit it's
So
loads
it
of
looks like it's a lot of plotly figures, right?
so
It's a
there
lot
are
of
really
plotly
lots of
figures,
plotly
not the
so
fastest
there
to
are a lot
load.
of plotly figures that here are like 50 runs, and each run has 3 sequences. Each sequence has a few hundreds steps of track figures, and I just like fetch them all. And probably like I can here just limit the number of fetch figures to be able to analyze them. But the bottom line is that Figures Explorer have to visualize all the track figures to the two-dimensional space and be able to compare them visually and learn some patterns. I can to visualize this more in a more in an easier way. I can just go to the all tracked runs and navigate to, for example, to a single run, and just a moment, see what figures are tracked here. So for example, in the latest run, there are 3 figures tracked with volumetric named volumetric validation, and I can query and see them.
It looks
1
to be
second.
empty.
Yeah, probably. Yes. So when it loads, so the bottom line is that. So this is just Explorers and Figures Explorer as well helps to fetch and visualize plotly for particularly for plotly and matplotlib figures actually. And it's very easy to add another adapter for certain type of visualization library that you use. You can add just a few lines of code and track your own type of figures and visualize them via AIM to be able to learn how model behaves through the training process.
So Gaurav, now that these plotly figures are taking forever to load, can you show, I guess, one last cool trick on Explorers before we leave? Leave for the questions.
Yeah, probably one cool trick will be 1 second. Yeah. What explorers actually enable, I just mentioned that they enable to fetch and group data and also have different type, arbitrary type of manipulations over the fetch and group data. One of the key features that community loves the most actually is that you can write arbitrary types of search expressions. So AIM supports a Pythonic query language. That is, you can filter over track data writing in Python, writing Python expressions. So for example, I have just write metric.name that ends with last. I can add also, and just this is pure Python expression. Think of it like writing an if expression, and you can just add run h params learning rate equals to 0.001, for example, and it will fetch all the runs corresponding to this learning rate and to this metric name. I probably there are no runs with learning rate 0.1. Let me fetch all the data to write a more realistic scenario. But you can write any arbitrary Pythonic filter question on top of your track data. So where is so for example, max k, I can fetch all the runs where max k equals to 1. So there are already 17, 20. So almost the majority of track runs have max k that equals to 1. This is just a very basic example, but you can write much more comprehensive expressions that can include starts with, that can include built-in functions like any, like max, or other Python functions. So basically, we can write very granular Python expressions, and when you have large number of tracked runs or large number of tracked sequences, you can select them very granularly and have all the other visualization, manipulations, grouping, aggregations on top of them. And also the second part is that you can actually group them by any hyperparameter that was tracked. As I already said, that can be hyperparameters, that can be dataset metadata, that can be parameters attached to a single metric, so to a single sequence, yeah, and so on.
Awesome. Thanks, Gor. Thanks a lot for getting this deep into the world of explorers. Also, I think we need to look at the figures explorer, but that's another story.
Yeah,
looks like an issue is being opened up. That's been that's not the figures.
Yeah, of course.
So
this is
let's open up for questions. If there are questions, and we're happy to answer. Otherwise, this would be it. And thank you everyone for joining in.
Yeah, but just a very quick question. Thanks for organizing this first.
Thank you so much.
In the Explorer, what are the ways that I can use to explore among all my experiments? Like if I want to quickly browse among them and have a look, because maybe I have, I don't know, hundreds of experiments and want to have a quick way to remember what is in what and what is not. Is there any way of doing that in the Explorer?
Yeah, so AIM have a general page when you can see all your tracked runs associated with experiments. For example, this is the runs explorer. Here is the list of all runs, and actually you can go to a single run page and see overall run associated metadata, and you can see the experiment that the run is attached to. And there is a way to also see the experiments. Actually, on the homepage, you can see, so here are 12 experiments. You can see the number of experiments, and you can navigate to a certain experiment, for example, to GMA syntax, which is an experiment in the scope of this neuron translation task. And you can go to this page and see how many runs this experiment contains. Here are, for example, 5 runs. 0 archived, or runs.
So just to kind of, sorry, Gor. Yeah, go ahead. Okay, sorry.
Yeah, so you can also navigate and see all the runs attached to this experiment, and you can also leave notes for this certain experiment. For example, this experiment contains runs where architecture is LSTM, for example, and leave other notes, so you can later on come back, or other teammates can come back and see what this exact experiment represents and what runs are attached to it. So there is the way to track runs. There is the way to attach run to a certain experiment page, which is basically grouping, and you can attach nodes to experiment to later find out what each experiment represents and see the attached runs. And also, I would mention that there is a way to query runs by an experiment. So you can basically go to Metric Explorer and also query certain metrics or certain sequences that belong to a given experiment. So for this example, I can write also and run experiment equals to GMA syntax, and I'll be able to query all those metrics that belong to the runs that are attached to a certain experiment, which is GMA syntax.
Does this answer your question, Francesco, just to kind of double check?
Yes. And if I can ask further, is there any difference with the Explorer version 2 about this?
Basically, on this from this aspect, there are no differences. Explorers version 2 are just more performant and more extensible for power users, let's say. They just help page, and yeah. Yeah, Kev.
But I think another, if you can you open up the Explorer version 2, because if you do, also we didn't show the trick to how open the Explorer version 2.
Yeah, so explorers are available from AIM version 16, not available for this demo, but on newer versions, there is just one Explorer tab where you can click and there is the list of explorers. So in this version, explorers are located on the sidebar. In the new explorers, there is a single page when you can navigate between.
No, Gore, if you change the, can you go back to an Explorer, to a Metrics Explorer?
To Metric Explorer, yeah.
Yeah, it's underscore V2.
I guess actually, there could be also.
So there is. If you go to Metrics Explorer, just like this, and you just go on just go metrics underscore V2, the same URL. It's going to open the hidden version of Metrics Explorer that's available. And
so so for this version, we had this Metrics Explorer version, which is kind of hidden, as this was an experimental version by then. I can select blue on.
The big another difference that these explorers have is pretty much you have this higher, more like flexible control of what you want to see in terms of like this grouping, right? What you want to see in the rows and what you want to see in the columns. So there's the idea of like grouping metrics here is slightly bit different to what is like there's a traditional metrics explorer, in a way that you have this pretty much like Descartesian kind of it's like pretty much considered like set by set kind of multiplication type grouping when it comes to, so you can pick different kind of rows and columns and it just will divide across your screen kind of in the 2 dimensions. This may be even like a whole separate kind of seminar, because there's lots of stuff in behind, but
so
pretty much the idea is this kind of new UX.
So we thought that the UX, we also a bit tweaked the UX, and we added like titles to controls to easier distinguish what each control does, and also we added separated grouping options from one single grouping option, and you can see grouping by rows, by columns, and color and stroke. In your version, there is also a way to enables grouping just by grid. That's a common way to visualize the metrics that was enabled in version 1 Explorers. So this is just a bit of more granular, I would say, and more easier UX for new users. But if you are also
both of these explorers have found, to be honest, and we will try to take the other one out. We cannot, it seems. So these are kind of 2 different ways of looking at like grouping different metrics or different type of kind of records together. Yeah, I don't know, we should keep this in the main recording of how to access the V2. I was going to ask, then I forgot, like how to access the V2 Explorers. It's the secret menu.
Yeah.
Any more questions?
Just maybe one quick thing, if you have any thoughts or maybe future plan about this. Like sometimes when I have to type something in the filter and I want to filter, for example, for a specific experiment, if I have like hundreds of experiments, I don't remember how they're called. And so it's a bit of a struggle, because I have to go back to the runs, look for the exact name, and then copy and paste it in the filter. And if there is any plan for future, like auto completion or just drop down menu for which you can select, would be very cool. I think it would be simplify a lot the process of choosing the filters.
This is a very good question. So at first we added a very basic way of auto completion. So you can just write run, and there will be auto completion for hyperparameters that actually exist. And you have track, for example, experiment or duration or age params, for example, right? Let me see V2H params, and you can the auto completion works for tracked parameter keys actually. And what you're asking is there is an auto completion for track type of parameter values, and this is what we are thinking for adding in future releases. So when you like write equals, it will auto suggest different the values that you have already tracked. So for example, there could be like there are 3 values for learning grade: 0.1, 0.1 on or just 3, for example. It will auto suggest them as well. So I'm not I don't remember exactly if there is a GitHub issue regarding that. But if there are not, so feel free to open a GitHub issue. And we also think this is a very handy feature.
Very cool feature,
yeah, it will be definitely a very cool feature, and we'll add them in future to also have auto completion for not only keys but also for values.
Yeah,
thank you so much.
Thanks. Yeah, that would be great to have. Thanks a lot.
Yeah, thank you, guys. We gotta wrap up. Thank you so much. Thanks for everyone joining in. This was exciting. We're gonna make this like either once every week or once every 2 weeks. So there is a good number of them lined up, including with some guests that are not the authors of the project. So yeah, thank you very much, and thanks for your time and attention. And on to the next one. Have a great day.
Thanks. Bye-bye.
Thank you.
Bye-bye,
Bye-bye.
everyone.